this our webinar. Today we're here with Scholastics Mathematics specialist Oscar Moreno with the sponsorship of Books and Toys and a collaboration with Dizal, our great partners from forever. Teacher Oscar is responsible for most of my aha moments since 2020 because with his many years of experience, no, he doesn't show his age, and his several academic titles he got during his specialization in applied ICT, his master in educatronics, in his degree in mathematics, he was able to explain uh, in his YouTube channel all those little operations I've learned throughout my life, including during my engineering degree, but was never able to figure out why. I would like you to invite you to click on this link above that I've just uh, streamed, and you can go directly to his channel. I'm pretty sure you'll be amazed. Well, enough said. Let the presentation begin. Thank you very much, Oscar, for being here with us today.
Thank you so much, dear Bianca, and welcome, dear educators, to this amazing session in which I will be talking about Singapore's math as an authentic way to learn mathematics. And actually, I will be focused on this important question, why Singapore's math in Brazil? So let me share my presentation. Ready? Are you seeing my presentation already? Yes. Okay, great. Thank you so much. Perfect. So let's move on the next slide. The idea for this session is that you will be able to answer the following questions. How can I develop the 21st century skills in my students? Actually, I will be focused on this first question because according to the last update of the Singapore's math, the Ministry of Education for Singapore has included the 21st century competencies or the 21st century skills as the second pillar in the Singapore's methodology. So in the update from 2013, they just focus on problem solving as the center of the classroom, as the center of the math classes. But in the last update in 2020, they have included these 21st century skills as the second pillar of their methodology. That's why we will be talking a little bit about 21st century skills and how you will be able to develop them, how you will be able to develop these 21st century skills in students using the Singapore's math. Second question is, what is the CPA approach and UPAC Plus? These are two key concepts, two important concepts that usually every teacher uses when the teacher is applying Singapore's math to teach and learn mathematics. And finally, the last question is, how can my students build conceptual understanding on algebraic problem solving? Actually, the idea is to check a little bit the difference between the pre-algebra skills development and the early algebra development. Because Singapore's math is focused on the second point of view, the early algebra skills. We should develop these early algebra skills in preschool, in elementary school, and we will be able to do it using Singapore's math in our math class. Great. So let's start with the first part, 21st century skills. And why are these 21st century skills so important in the math class or in the classes in general? Because according to the World Economic Forum, these are the skills that every student needs to develop right now because they will be used them in the future in the working lives. We can see really interesting things. For example, if we compare the list of skills from 2015 and the list of skills from 2020, complex problem solving keeps the first position of both lists. So we have to continue working on math problem solving in the math class. And also, skills like critical thinking, creativity, communication, collaboration, or confidence, for example, are too important in the math class because students will be able to use all of them in order to solve real problems or real situations in their daily life. So let's explore a little bit the five C's or the five different skills that we should develop in the students in elementary school. For example, students have to develop critical thinking because with critical thinking, they will be able to identify different points of view, different strategies to solve the same math problem. Communication and collaboration are too important too because they will be able to overcome common mistakes. That's one big difference between the Singapore's math and the way to learn mathematics traditionally. Because when the students are learning mathematics using Singapore's math, they have to build deep conceptual understanding. So the teacher will be more like a guide. The teacher will be asking a lot of powerful and purposeful questions. And based on these questions, students will be able to develop the math competencies and the 21st century skills. Also, students will be able to develop creativity. This is too important. For example, when they have the possibility to solve a math problem using the 8 heuristics or the 8 different strategies considered by the Singapore's math. Traditionally, we have used only the 4 basic operations, like the 4 basic or the 4 different ways to solve a math problem: addition, subtraction, multiplication, and division. However, when you implement Singapore's math, you will see more than one strategies to solve the different math problems. These 4 basic operations will be only one of the 8 different strategies which students have in order to solve a math problem. And finally, students will feel more confident in your math classes because they will be working on mathematics using the CPA approach. CPA means concrete, pictorial, and abstract. 3 math representations related to the 3 different cognitive phases according to Jerome Bruner's theory. Students will be manipulating physical things or physical objects. Then they will be using drawings or diagrams in order to make sense on the math concepts. And finally, students will be working on mathematics through the abstract representation, in which they have to use the proper math vocabulary. So just to give an example, let's explore a little bit critical thinking. For this skill, for this important 21st century skill, I have an activity for you, my dear teachers. And I will really appreciate if you answer or if you share with me your answers through the chat box. So the question or the activity is, we should complete this definition perfectly. So my dear educators, what words would you use to complete this definition? Critical thinking is first blank and another blank, focus on deciding what to believe or do. What are those 2 words that you will use to complete this definition perfectly or correctly? Please share with me your answers into the chat box. Okay, someone is typing. Okay, that's right. Sometimes this exercise can be a little bit difficult, I know, because we know a lot of definitions about the same concept, critical thinking. But according to your experience, your great experience, like math teachers, like teachers in the classroom, in the school. Okay, perfect. First word, important. Critical thinking is important, all right. And what will the second word be? What another word would you use to complete this definition? Critical thinking is and Focus on deciding what to believe or do. I'm going to use the first word that you shared with me, important. Critical thinking is important. And what is the second word? Reflective. Okay, thank you so much. Perfect. Thank you for your participation, my dear teachers. Now let's see the two words according to this definition taken from this research article. So, critical thinking is reasonable and reflective thinking, focus on deciding what to believe or do. Okay? So, according to this definition, the first question that every teacher has in this meeting is, how can we develop a reasonable and reflective thinking focus on deciding what to believe or do in my students using Singapore's math, for example? So, according to Singapore's math, we can develop critical thinking using the Polya's problem solving techniques. George Polya, a Hungarian mathematician in 1945, uh, proposed four different principles or four different stages that everyone has to take into account when this person wants to solve a math problem. The first stage or the first principle is understand the problem. At this stage is too important the questioning exercise in which teachers, students have the opportunity to interact about or around the problem that we are proposing in class. That's why when a student doesn't understand the problem, we can't give this instruction, read again the problem. Instead to say that instruction, you can ask previous questions to ensure the understanding from the problem. For example, if the problem is talking about Oscar has 9 apples, for example, we can ask a question related to this first part of the problem. Who is the main character in the situation, for example? Or how many apples does Oscar have? So instead to say, read again the problem, we are asking questions and students need to read again the problem to answer those previous questions before to answer the main question in the problem. Then the second stage is plan. Students will choose the most appropriate strategy to solve the math problem. That's why Singapore's math proposes 8 different strategies that you can consider in your classes when you are implementing Singapore's math. Imagine your students acting out the problem, and this is completely fine. Or, for example, if your students are drawing or making a diagram in order to find the solution of the problem. The third stage is carry out the plan or answer the problem or the situation. In here, students need or the students need is care and patience, and they need to use the strategies or the strategy that they have considered in the previous stage in order to solve the problem. And finally, the last stage is look back or check the answer. So this stage is too important because they will identify pattern solutions in order to apply them in other future problems related to the problem that they are solving right now. So that's why students will be able to identify the additive or the multiplicative structure in a problem instead to identify keywords. The biggest problem when we are teaching Singapore's math is to teach the keywords in the problem. When you say, students, if you see the word total or in all or all together, it's because the problem is about addition. Or if the problem has the word times, it's because the problem is about multiplication. The problem is students will put these keywords in their minds, and if they don't see these words in the problem, they will say, teacher, I'm not understanding the problem. I can't see these keywords, so I don't know if we have to use an addition or a multiplication or a division to solve this problem. So instead to teach keywords, we use or we teach these principles, students will be able to recognize the most effective strategy to solve the problem. So now, my dear teachers, let's see an example. But before to see this example, I have to mention something. We have to model the 4 stages or the Polya's problem solving techniques explicit in the math class. So we have to teach the understand stage, plan, answer, and check stages in the classroom, especially in first grade, because students need to develop this confidence on this process or these stages to solve the math problem. And also in the second stage or at the second stage, when the students are considering the different strategies to solve the math problem, we have to provide many resources, many possibilities to practice the problem solving skills using the 8 different heuristics or the 8 different strategies. So now, my dear teachers, I want to share with you one didactic strategy that I usually use in my class in order to teach these strategies and how students can develop that skill to identify the most effective strategy to solve the math problem. For example, let's consider this problem. In a room with 8 people, everyone shakes hands with everybody else exactly once. How many handshakes are there? So remember, according to the Polya's problem solving techniques, students need to understand the problem. At this stage, we can ask questions related to the specific situation, some questions related to the real situation, and some questions related to the math context. For example, in the first part, it says in a room with 8 people. One question can be, how many people are there? So students need to read again the problem and they will say, teacher, in the room, there are 8 people in the room, sorry. Okay? Then the second part says everyone shakes hands with everybody else exactly once. So one question can be what happened in that room, all right? So they will say that everyone shakes hands with everybody else exactly once. And finally, what do we have to do to find the solution of the problem, not the answer? This is one of the most interesting strategies when you are teaching problem solving. If you want, my dear educators, give the answer to your students, and they won't focus on the answer. They will be focused on the solution. For example, according to this problem, the answer is 28. I'm not interested in the answer, dear students, you can say, okay? The answer is 28. I want to know how you reach that 28 using one strategy that we have according to Singapore's math. So the problem is now more interesting for them because they have to find the process, they have to find how to look for the answer 28. So then in the second stage or at the second stage, students need to find or need to choose the most effective strategy to solve it. Obviously, this exercise is really good when you are teaching in fifth, in sixth, or fourth grade because the students have experience already on the Singapore's math and the different key concepts on Singapore's math. However, when you are teaching in first grade or second grade, you can't wait or you can't hope your students, you can expect your students find the most effective strategy at the beginning. We have to teach that. So the question now is how can we teach this in the math class? One of the strategies is you can provide one of these heuristics to every student in your classroom if you want to work individually. But if you want to make some groups in your classroom, you can assign one of these strategies to each group in the classroom. For example, group number 1, you have to solve the problem using act it out strategy. Pro, uh, Group number 2, you have to use draw or use a diagram or a picture to solve the problem. Of course, all these strategies don't work to solve the problem, but you don't have to say that to your students. The students need to discover this by themselves. They have to say, teacher, you said that I have to look for patterns in order to solve the math problem, but we couldn't solve the problem using this strategy. That's completely fine. So in that case, you will say, okay, guys, so what of these strategies is the most effective to solve that problem? If look for patterns, for example, doesn't work. So students will see, will recognize pattern solutions that they can apply after in future problems similar to this one. So now, my dear teachers, let's do the exercise. I'm sorry, before to do the exercise, I want to propose this activity for you. Please, my dear educators, choose one of these strategies. Act it out, draw or use a diagram or picture, make a list, choose an operation, guess and check, look for patterns, word by word, solve part of the problem. And let's take 2 minutes to try solving the problem, please. All right, so please take a sheet of paper or a notebook that you have in your desk in the place that you are right now and try to solve the problem using that strategy that you have chosen. Okay, someone's are telling draw a picture, draw a diagram. Someone says make a list. Okay, perfect. But now try to solve the problem and try to get the number 28 because 28 is the answer of the problem. How many handshakes are there? There are 28 handshakes. Now the problem is how can we get that number 28? Okay, let's take 1 minute, my dear teachers, my dear educators. And if you want to share with me the strategy, the heuristic that you have chosen, please put it into the chat box. Okay, most of you said draw. Okay, perfect. Draw a picture, draw a diagram. Perfect. Okay, that's right. So that means that you're using a pictorial representation to solve the math problem. Great. Okay, so now let's see, my dear educators. I'm going to show you some strategies that my students have used in order to solve this problem. And actually, I'm going to analyze each of these strategies as my students analyze the problem and the solution of the problem through the strategy that they have chosen. Someone says act it out with a string, maybe a wool, okay, exchanging each person only once. I love it. I love it. That's right. Great. Thank you, Vania. Perfect. So now, my dear teachers, actually, the first strategy is act it out. These people, these students were so excited in the math class, especially because this class was in the morning at 7 and a half, more or less. All right. Someone's were sleepy. So this was a really, really amazing warm up activity because they raise their hands, they stand up from their desk, and they act the problem. And finally, one of these students was counting the amount of handshakes in the room. And finally, this student got 28. Okay? They solved the problem using a strategy which is included in the different strategies according to Singapore's math that was completely fine. Okay? Now I'm going to show you another strategy from another group. This group uses this strategy, draw or use a diagram or picture. So they make this diagram using the first letters from the alphabet from A to H, and then they drew some lines representing the amount of handshakes in the room. For example, from A, they count 1, 2, 3, 4, 5, 6, and 7 handshakes. As the problem said, everyone shakes hands with everybody else exactly once. That's why they didn't consider the handshake between B and A, because they count already the handshake between A and B. In that way, they count the amount of handshakes from B. 1, 2, 3, 4, 5, and 6. Then they continue drawing the different lines representing the handshakes in the room for every person in the room. And at the end, they got this number sentence, this addition. They added 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, and they got 28. So if we compare this strategy with the previous one, we can see clearly in this strategy, they are using math vocabulary at least. They are writing math vocabulary at least. They are using the additive structure to solve the problem, to find the solution of the problem. So the first strategy was a really nice, a really interesting warm-up activity. But in this strategy, they are using an addition. So how can we help the students from the first group to know this interesting strategy? At the end of that first part of the activity, you can meet the group number one, the group number two, and they can discuss among them the solutions and the strategies they have used to solve the math problem. In that way, the students who used the acted out strategy will know another strategy to solve the same math problem using drawings and an addition. And these people or these students who used the addition and drawings to solve the math problem, they will know they can add the problem in order to solve it. Okay? Now let's see another strategy, my dear teachers. This one, I really love this one because this group made a list, but this list was a little bit different. They made a chart with 8 columns, 8 rows, and then they put a check counting the amount of handshakes in the room. So they explained to me, teacher, I have to put a check between A and B because this counts as one handshake, right? And then they count the amount of checks on this square, on this chart, sorry, and they count 28 in total. They found the answer of the problem and the solution of the problem using a list. Why did they put these crosses on the bottom of this chart? Because according to these conditions, according to this problem or the second part of the problem, everyone shakes hands with everybody else exactly once. So if they count this handshake between A and B, they don't have to count the handshake between B and A. And that's why they also put some crosses on the diagonal of this chart because they said teacher A can't handshakes or can't shakes hands, sorry, with him or herself. So that's why we have to put some crosses on the diagonal and also on the bottom of this chart. So finally, they found the total amount of checks, counting the amount of checks, and they find the answer of the problem. This was really interesting because after this exercise, we could generalize the solution. For example, I told them, okay, guys, suppose there are 9 people, 10 people instead 8, or there are 100 people. Are you going to make a list? Are you going to make a chart with 100 rows and 100 columns? They said, oh no, my God, teacher, that would be really long. Okay, so how can we generalize this answer, this solution with 8 people in order to answer my second question? Imagine that there are 100 people instead 8. So after that, we could get this formula or this way to solve the problem. They realized multiplying A times A, they found 64 cells in all on the chart, but then they subtract the number 8 because there are 8 crosses on the diagonal line on the chart. And finally, they divided this result by 2 because there are 2 triangles on the chart. This one on the top and this one on the bottom. And finally, they found 28. So in that way, they could get the different answers, the different solutions if they consider more than 8 people in the room. Okay, great. So now let's see this one. Look for a pattern. In this case, they made a chart with number of people in the room, number of handshakes, and according to this information or according to the number of people in the room, they complete the number of handshakes column. For example, if there is one person in the room, there would be 0 handshakes. If there are 2 people in the room, there would be 1 handshake. And they were completing this chart on that way, and they found the answer completing the 8th row on the chart. 28 handshakes in all if there are 8 people in the room. This was another interesting solution or another interesting strategy because they recognized the triangular numbers using this strategy. For example, let's see the triangular numbers here. If we check the number of handshakes column, we can see the triangular numbers from 0 to 28. Imagine this problem was taken from a book of 3rd grade, and the students in 3rd grade are talking about triangular numbers, a math concept that usually we learn as mathematicians, as math teachers, maybe in the 2nd or 3rd semester in the university when we are learning mathematics. But the students in 3rd grade are learning about triangular numbers using a different strategy according to Singapore's math. So now, my dear educators, just to reflect on this thought, if we compare this strategy with the first one acted out, which of them is the most effective, not only to solve the problem, to learn mathematics? Of course, the answer is this one, right? Because students are learning mathematics, triangular numbers, for example, using another strategy, which is the most effective to solve the problem and also to learn mathematics. Great. Perfect. So now CPA approach, taken from Jerome Bruner's theory. Students learn to make connections between physical materials, visual representations, and mathematical symbols. The concrete, pictorial, abstract approach develops deep conceptual understanding on math concepts. That's why uh, I want to mention that Singapore's math, it's a really amazing methodology that we can implement in Brazil, for example, in the classroom, in order to help students to learn mathematics and also to help them to develop 21st century skills as critical thinking, because the students are considering not only one way to solve the problem, they're considering more than one way to solve the same problem. They have the possibility to communicate, to talk, to discuss about the solution that they are using to solve the same math problem. Great. Okay, so now just to give an example about CPA approach. So let's solve this problem, my dear teachers, my dear educators. Carla had 2 liters of milk. She drank 2 quarters liters of this milk. How much milk was left? I know, traditionally, we told to students, you have to subtract 2 minus 2 quarters. And probably your class was focused on how to solve that subtraction, how to multiply and cross or use the cross multiplication, and then to simplify the answer. That's right, because that's the abstract representation that the students need to learn at the end of the process. But previously, they have to make sense behind of this procedure, behind this algorithm. That's why we have to make sense on this math concept using the concrete experience and the pictorial representation. So now, my dear teachers, I will invite you to scan the QR code on this slide. You have to open the camera of your cell phone. You have to put your cell phone in front of your computer or your laptop, and then this QR code goes to a website completely free in which you can use some virtual manipulatives. All right, so please let's scan the QR code because I'm going to share my screen in order to show how to solve the problem using the manipulatives, okay? Obviously, I'm going to use virtual manipulatives, but the idea is to use physical objects or physical manipulatives in the classroom. Great. Okay, so now let's share my screen. Wait a minute, my dear educators. All right, so I'm sharing my screen right now. Okay, great. Perfect. So now, as the problem said that Carla had 2 liters of milk, I'm going to move 2 of these holes, all right? And now it says, the problem says that she drank 2 quarters. So the first thing that we have to do is to find the equivalation between these 2 holes and the quarters tiles. That's why I'm going to move some quarters, all right, on this row. 3, 4, 5, 6, 7, and 8. And now students are able to see the first equivalation between a whole number and a fraction. 2 holes are equivalent to 8 quarters. So if Carla drank 2 quarters, we have to remove 1 and 2. Now we have to count the amount of quarters which are left, and we are able to solve the problem, all right? Because Carla, sorry, 1, 2, 3, 4, 5, 6 quarters of milk, sorry, were left. However, this answer can be simplified, right? We can simplify this answer, and maybe your students or you have seen your students a little bit confused with this concept in mathematics, the simplification of fractions. Maybe because we are focused on the abstract representation. We are focused on teaching how to simplify using the division, all right, of whole numbers to find the simplification of this fraction. So now I'm going to use the same manipulatives to find the simplification of this fraction 6 quarters. How? Moving 1 whole over here, because the first 4 quarters are the same to 1 whole, and these 2 quarters are equivalent to 1/2. And we have found the answer of this problem, the solution of this problem, using only virtual concrete material, okay? Because the answer is 1.5, okay? Great, so let me go back to my presentation. I'm going to stop sharing my screen. I'm going to share my presentation again. Perfect, okay. So this is how you can solve the problem using concrete material, using virtual manipulatives, okay? Now, students are able, when they understood this very well, they are ready to solve the same problem, for example, using the pictorial representation. So in this pictorial representation, I'm going to use the VAR model, another key concept of Singapore's math that maybe can be another topic of one of these fantastic webinars, okay? But in this case, I'm going to use the first part to represent the first 2 liters according to the problem. The second part is representing the amount of quarters, the 8 quarters, which are equivalent to the first 2 holes or those 2 liters. And the third part is representing 1.5 liters, the amount of the amount of milk which was left, 1.5 liters. Of course, when the students are working on the problem through the concrete experience, the pictorial representation, they will understand much better the abstract representation, because now they are focused on the answer of these questions. For example, why did we change the number 2 but by 8 quarters? Probably, if you haven't seen the concrete experience and the pictorial representation, your answer will be because 8 divided by 4 is equal to 2. That's completely fine, but not in this context. All right? So that's why we usually say yes, because 8 divided by 4 is equal to 2. And remember that every fraction, before to be a fraction, is a division, is a representation of a division. And the students will say, yes, teacher, but they are not understanding anything, I'm sure. But instead, to explain that in that way, You can say yes, 2, or we change 2 by 8 quarters because 8 quarters are equivalent to 2 units or 2 wholes. Did you remember the concrete representation? Yes, teacher, I remember that we move some units, 2 units or 2 wholes, and then we saw that 8 quarters are the same to 2 wholes together. So now they're understanding much better the procedure, this algorithm behind, or the concept, sorry, behind this algorithm. Okay, so this is only one example, a simple example how the CPA works, CPA approach works. One of the most important concepts in Singapore's math. Great, so as I told you, we are working a lot on mathematics through the 3 math representations, the concrete experience, which is completely aligned to the first cognitive phase, enactive, in which the manipulation of physical and virtual objects are too important to understand, to generalize, to ask more questions related to the concept or the problem, and also the pictorial representation in which students, pictorial representation is completely aligned to the second cognitive phase according to Jerome Bruner's theory, which is iconic, in which students will be using drawings and diagrams in order to make sense on the math concepts. And finally, they will be working on the abstract representation using the proper math vocabulary, but they arrive at this stage, at this representation with a big difference. They have recognized, they have made sense on the math concept through the concrete representation, through the pictorial representation. Okay, my dear educators, do you have any questions so far? How did you see this? No questions so far? Okay, perfect. Right, my dear teacher. So now let's see something which is interesting. And also, I put this in the description or the abstract of this talk. I put in this abstract that you will learn about how to develop early algebra skills in the students and why Singapore's math points to early algebra instead pre-algebra. They were pointing to pre-algebra skills in the first update of Singapore's math from 2013, but with the last update from 2020, now Singapore's math is trying to reach the development of early algebra skills. Why? Because we have many advantages using or developing this early algebra, especially in preschool and also in elementary school. But it doesn't mean that you have to teach now equations in first grade, of course. You don't have to teach that in first grade or second grade. Or some students are solving for X or for Y in an equation in third grade. You can teach the traditional or the basic math concepts in a different way. And this teaching will be really useful to develop these early algebra skills. For example, according to some research articles, algebraic or early algebra skills summarize some concepts, some topics that we have to teach in the math class in order to develop them. For example, algebraic reasoning or early algebra includes make connections, abstractions, and generalizations. Or, according to this, we have to solve specific problems or classes of problems to develop these early algebra skills in the students. So now, my dear educators, because of time, of course, I'm going to show you some examples, 2 or 3, how you can develop early algebra skills in the students using Singapore's math in the math class. So this is only a summarize what algebra or early algebra is. Of course, in elementary school, it means function and variable introduction, generalization of laws, connections and abstractions, and the solving of specific problems or classes of problems. All right, so before to show you these examples, I want to show you the two different points of view about algebra learning difficulties. For example, when you are worried about the pre-algebra skills development, you will be focused on abstract concept teaching. For example, how to solve an equation, how to organize an algebraic expression, how to move one term from the right hand to the left hand or from left hand to the right hand. And when you try to find the difficulties from students about algebra, we usually say that it means a student's cognitive development limitations. So that's why this point is the most interesting point, and that's why Singapore's math has changed, right? Their pedagogical principles to develop early algebra skills instead pre-algebra skills. Because when you are focused on early algebra skills, you are focused on how to improve algebra teaching. That's why you are looking for algebra teaching strategies all the time in the math class. And also how to teach math concepts using different representations or different ways. So that's why, for example, when you are working on algebra in Singapore's math, you can introduce the multiplication as a quaternary operation instead a ternary operation. Why is a ternary and a quaternary operation? The multiplication is a ternary operation when you teach it like the product of two factors. You have two numbers that you multiply and then you will get a product. For example, 2 times 3 is equal to 6. That's why traditionally in the last years, we are always focused on the timetables or the multiplication tables. I'm really worried that all my students learn the timetables from 1 to 12 because that's too important for their life. These timetables are too important because they will understand much better the division process in 4th or 5th grade. Yes, that's right. In the past. Now you have to focus on the focus on teaching or math teaching in a different way. For example, the multiplication. Now we can teach multiplication as a quaternary operation instead of ternary operation. How can we teach the multiplication as a quaternary operation? As the relationships that we have among four different amounts or four different numbers. For example, when you consider the multiplication as a quaternary operation, students will be able to identify two different relationships, the scalar relationship and the functional relationship. When you teach these relationships in the classroom, in the math class in elementary school, students will be able to learn will learn easier the concepts like function, like relation, that they usually see or they usually learn in 11 or 10th grade. Hmm? Okay, so now let's see an example. Sorry. Let's see this problem or let's try to solve this problem. Traditionally, if we're focused on pre-algebra skills, we are worried about the equation which models this problem correctly. But this is a big question that maybe some of you have, or I had this question when I was teaching or when I'm teaching this topic. How can I teach to my students to model this problem using variables and numbers? That's a big problem. But this is not a big problem when you use, for example, the VAR model, which is a key concept of Singapore's math. How can we do it? So in the problem, we have three different characters, Julio, Moan, and Devi. Now let's represent the first part of the problem. It says Julio is 8 years old. So I'm going to draw a bar, and this bar is going to represent age. Age is Julio's age, right? Now the second part says Mohan's, sorry, Mohan's age is 1/3 of Julio's age. That's why I have drawn this Mohan's bar as the third part from the Julio's bar, because the problem says Mohan's age is 1/3 of Julio's age. So it means the third part of Julio's bar. And finally, the last part says Devi is 5 years older than one. I'm sorry, one H is missing here. I'm so sorry. Devi is 5 years older than one. So that's why I have drawn this another extra part on the Devi's bar, and this is representing the 5 extra years on the Devi's bar. So now based on this bar model, I'm sorry, there's another important data. If Devi is 8 years old, Devi is 8 years old, sorry, this bar is equivalent to 8, right? According to the last part of the problem. And we have to look for the Julio's age. So now based on this bar, we can set up or we can write the correct equation which models this problem. Because 1/3 age, look, this is 1/3 age, this part of the bar, plus 5 is equal to 8. So that's why we have this first step on this equation. And now we are going to solve this equation. For example, traditionally, we have thought that we have to pass this number 5, which is positive or which is adding, to the other side as a negative number or subtracting. But now, based on the VAR model, the number 5 is subtracting, not because it was adding in the other side. This is because we have to find the value of this part from this bar, all right, on the Davis bar. So if we subtract 8 minus 5, we will get 3. 3 is the value of the missing part from the Davis bar. And at the same time, the Mohan's bar has the same length of this part of the Davis bar. That's why Mohan's bar is equal to 3. And finally, in order to find the Julio's age, as Julio is 3 times Mohan's bar, we have to multiply by 3. And we got 9. The answer is 9. Julio is 9 years old. But this number 3 is not multiplying because 3 was dividing the other side. This is because Mohan's bar is the third part of the Julio's bar. Okay? This is another problem, my dear teachers. Ali read 10 pages of her favorite book on Monday. Or someone say it's difficult. Okay, yeah, it probably can be difficult because this is the first time that you are seeing the VAR model. But the VAR model is really helpful for students and really useful for students to understand much better mathematics. Actually, my dear teacher, let's see this problem. If your opinion is the same, maybe after this problem or it will change, okay? It says Ali read 10 pages of her favorite book on Monday. Ali read 1/3 of her book on Tuesday. If there are 24 pages more to read, how many pages does the book have? How can we solve this problem using formal algebra, using equations? This one. This is the equation which models the previous problem. And at the end, we find the answer 46. The book has 46 pages. This can be a little bit difficult because we're introducing variables, we're introducing numbers, we're introducing equations. But now, what if we use the VAR model? Look, this bar is representing the 10 pages of her favorite book on Monday that Ali read, okay, on Monday. In the second part, we have Ali read 1/3 of her book on Tuesday. It means that we have to draw another part on the same bar. It has to be divided into 3 equal parts because the problem says that Ali read one of these 3 parts of her book on Tuesday. So this first third is representing the amount of pages that she read on Tuesday. Now, in the third part of the problem, it says if there are 24 pages more to read, so it means that these 2/3 are the same or equivalent to 24, okay? The question is how many pages does the book have, all right? So now based on this bar model, look, my dear teacher, this is completely easy. I know, and you will see it. Okay, it's too easy. We can find the amount of pages based on this bar. How? For example, in the last two pieces, the last two thirds are the same to 24. So if there are two units, or these two thirds are the same to 24, it means that one of these thirds or one of these units is equal to 12. So now if there are three, 1, 2, and 3, 3 units or 3 thirds are equal to 36. And then we added the amount of pages that she read on Monday. 10. 36 plus 10 is equal to 46. And we found the answer again. The book has 46 pages. So now the teacher from 6th or 7th grade will introduce the x as a variable, replacing the var by the letter, by the variable x or y or a. All right. And now the path from the early algebra skills to the formal skill, or sorry, the formal algebra will be easier for them because they will understand much better the concept behind the equation that they are using to solve the math problem. Okay. Okay. And finally, my dear educators, what questions do you have? So now I want to share with you, before to listen or before to read your question, sorry, I want to share with you something really interesting. I'm going to, or I want to invite you to click on this button that you will see. I'm sorry, that you will see above. This is really amazing because this is an interview, an article from a magazine in Brazil of one of our teachers who is using Singapore's math, who is implementing Singapore's math in her math class. So I'm going to add this button right now. Wait a minute, please. Great, ready. So if you click on that button above, you can go to that magazine and you can, or you will be able to read this interesting article on page 16. Okay. So my dear teachers, any question? This is my email, omoreno@scholastic.com. If you have any question after this session, if you have any doubt about Singapore Snap, I will be more than happy to reply to your emails. Okay, dear Bianca? Okay, my dear teachers, dear educators, thank you so much for your time. Please, if you have any question, don't hesitate to reach out to me. I will stay tuned. Okay?
Thank you very much, Oscar, for
Thank you so
being with
much.
us today.